Assalamu alaikum. We are still in silicate minerals, and we discussed the primary silicate mineral, which is include six type with different silicate unit. I told you that there is nesosilicate, and example for nesosilicate is olivine minerals, inosilicate like pyroxene and amphipol, phyllosilicate like mica, tectosilicate like plagioclase and feldspar, ordosilica like quartz is included to tectosilicate. Sorosilicate like epidote mineral. Now on this section I will discuss and explain clay minerals, which is classified as a secondary mineral. It's formed from mica minerals, phyllosilicate, after some reconstruction and some chemical composition transformation. Before go deeply on clay mineral, I would like to understand and imagine something. I would like you to put in your consideration that the oxygen ion volume is larger than hydrogen ion, and the hydrogen ion is very small compared. The hydrogen ion is very small when compared to oxygen ion. Consequently, when I told you a unit of octahedra, not tetrahedra, we discussed together tetrahedra, isn't it? There is a unit also in clay mineral called octahedra. Octahedra is consist of six hydroxyl ion. The hydroxide ion looks like oxygen ion. Why? Because the hydroxyl ion composed of oxygen ion and hydrogen ion. The hydrogen ion is very small, and consequently it looks the structure of octahedra looks like a structure of oxygen like tetrahedra, because you can neglect the volume of hydrogen ion with respect to its volume. Clay mineral. The clay mineral is a secondary mineral, consists of two units. The first is octahedra and the second is tetrahedra. The tetrahedra on is on phyllosilicate shape, while octahedra has this shape: 3 oxygen ion or hydroxyl ion on a level, and the other 3 on another level. The space on octahedra is larger than the space in tetrahedra. For this reason, this space is generally not occupied by silica, because the silica is very small compared to its higher volume, so it is occupied by aluminum or magnesium and iron. So if you have a look to the size of iron again, to be able to imagine, silica is found on tetrahedra. Alumina also can found on tetrahedra and found also on octahedra. Alumina can be found on octahedra. Alumina and iron, manganese can be found on octahedra, because as I told you, the space on octahedra is larger than tetrahedra. However, in tetrahedra, you will find silicon and aluminum. So here is tetrahedra space, silicon or aluminum only. In octahedra, because like this, but 4, imagine here 4 or 3 on this level, and the other 3 on the opposite direction. Leave a larger space in octahedra. As I told you, the hydrogen is like a dot on a ball. Again, here is tetrahedra, 3 on a level and 1 on another level. Here is 3 on a level and 3 on the other level. Also, you can imagine that it looks like 4 on a level and 1 on the top and 1 on the bottom. On clay mineral, it consists of 2 sheets. The first is tetrahedral sheet, and you know what the meaning of tetrahedral. The second sheet is octahedral sheet. Take this shape. In another way, the structure of clay mineral as a secondary mineral consists of sheet of tetrahedral, silica tetrahedral, and it has, because it's a phyllosilicate, it has a chemical composition of SiO5, and trioctahedra, and octahedra, which is consists of 6 hydroxyl ion. There is a proton here, O minus 2, and H, the net will be minus 1. Octahedral sheet divided into 2 types. The first type is dioctahedral. 2 sides, dioctahedrals, 2 of 3 sides occupied by metal, by aluminum. Trioctahedra, 3 of all of sides. There is a sides here, sides يعني empty space. To reach the equilibrium, due to aluminum has 3 positive charge and OH have 6 negative charge, to reach the equilibrium, you should take only 2 aluminum for each 6, because it is a phyllosilicate, a silicate layer, an octahedral layer. For each 2 sides, for each 3 sides, only 2 occupied by aluminum to reach the equilibrium. Here, on trioctahedra, all of sides are filled by magnesium to reach equilibrium, because Mg is plus 2 while OH negative 6. So here to summarize what we mentioned, the clay minerals are divided based on the number of cation sites occupied in the octahedra layer. If the central cation is triple, like aluminum, then only 2/3 of the cation sites are occupied to balance the charge, and this structure is called dioctahedra. However, if the central cation binary, metal like magnesium or iron, then all cation sites are occupied, and this structure is called the trioctahedra. Method of building clay minerals. The Si tetrahedral sheet, silica tetrahedral sheet, consists of interconnection of silicate tetrahedra unit with each other and extending in a horizontal plane, and we together discussed and I explained the sheet, or how the sheet of tetrahedra on ferrosilicate build. The Al or Mg octahedral is even di or trioctahedral sheet consists of bonding with each other and extending in a horizontal plane. Here is the octahedral. Look here, there is H hydrogen is not appear, but O is larger than hydrogen. Here is the aluminum, and here is the tetrahedra. These are the two units built the clay mineral. How it go, I will explain. Another shape of tetrahedra, silica tetrahedra we mentioned, and the octahedra. This is another shape on 3 direction. There is a 3 and 1 on the top. This is silica tetrahedra we discussed together. This is aluminum octahedra. Different shape to be able to imagine. So, look, here is the Al alumina octahedra, called usually dioctahedra because only 2 of 3 sides are occupied by alumina, called gibbsite layer, while Mg octahedral called trioctahedral or brucite layer. So we have different type of clay mineral. The first is 1,1 minerals groups. In 1,1 minerals group, there is usually found 2 layers. A layer of tetrahedral and a layer of octahedral. 1 unit of silica tetrahedra and 1 unit of octahedral, even Al or Mg. The second type is 2,1 mineral group, 2 unit of silica tetrahedra and 1 unit of octahedra. There is 3 layers here. In 1,1 mineral group, there is only 2 layers, a layer of tetrahedra and a layer of octahedra. In 2,1 mineral group, there is 3 layers, a layer of silica tetrahedra, then octahedra, and then tetrahedra again, silica tetrahedra again, 3 layers. 2 of tetrahedra and 1 of octahedra. If you have a mineral of 2,1,1 mineral group, this means that you have 2 units of silica tetrahedra and 1 unit of octahedra, and plus 1 unit of octahedra again, of magnesium octahedra. We will explain together again this type of mineral. Let's see this shape for 1,1 mineral. This is an tetrahedra, as you see, 3 and 1, and this is the octahedra. So if these bonded with each other as this shape, if you have 1 tetrahedra and 1 octahedra, the mineral is then called 1,1. But if you have 2 tetrahedra and 1 octahedra, the mineral is then called 2,1,1. Look here, 2,1,1. But when tetrahedra bonded with octahedra, it lost 2 hydroxyl ion. So here 2 hydroxyl ion will be lost, and here also 2, so the sum is -4 OH.